Hello. Hello.
Hello, good afternoon.
How are you today?
I'm doing good. How are you?
Well, thanks. Just if we'll start in a few minutes. I was very busy this week. So,
Okay.
but just be patient, okay? I will have it probably by tomorrow night. I will have
Tomorrow night. All right. Thank you.
welcome. Let me welcome this person. Make sure we're on the right page. Okay, good. I think we can start. Now, I'm going to share my screen, but before that, let me remove some. I opened so many pages. So I'm going to close some of them so we can begin. Good. So the new share is this one. So I introduced you to the concept of probability on Monday. Today, we'll be looking at we'll go deeper into the concept. Let me put it that way. Let's go deeper into the concept of probability. Now, today we'll be looking at classical probability. Remember, I mentioned that we have three approaches: the classical approach, the empirical approach, and the subjective approach. Today we'll start with the classical. So the classical is based on known sample spaces, because we already know the sample spaces of the event. We can use it to calculate the probability of those events. For example, the day of the week, the sample space is 7 because we have 7 days in a week. So if I ask you to calculate the probability that a day chosen was on Wednesday, we have only one Wednesday in a week. So we can be 1 out of 7 days. Another example is the dice. We know it has 6 sides. If I ask you the probability of any of the side of showing up when you toss the die, you're going to be 1 out of 6. Now, a deck of cards, there are 52 cards. If one card is selected, what is the chance that it's going to be a club? Now, we know that already know that the sample space is 52. So out of this club are 13 clubs, so that the probability that it's going to be a club will be 13 out of 52. So what I'm trying to say here is that for classical probability, we already know the sample space. They're based on known sample spaces. And then we use that to calculate the probability of the event. Let us see how this can, maybe two or three examples on this. It says here, let's look at number 4. I'm going to make it bigger. Number 4 says, a card is drawn from a deck of another deck. Find these probabilities of getting a jack, of getting a 6 of clubs, of getting a 6 or a 3. Solution for part A. Solution. Yeah. It's of getting a jack. Let us use J for jack. Jack is J. Okay. In that case, the probability of getting a jack, probability of jack, now becomes how many jacks we have. But before I do that, I can tell you this. I want to tell you this. Whenever we're doing a classical probability, like I already explained, this is the formula we use. Number of possible outcomes in which event E occurs, total possible outcomes in the sample space. So this is what I was saying when I gave you the example with the card, with the dice, and with the day of the week. It is based on the sample space, known sample spaces. Okay. Now, based on that, now you see probability of a jack. How many jacks do we have in the deck of cards? You can see jack right here. We have 4 jacks. 1, 2, 3, 4. So the probability that the card was drawn is a jack would be 4 out of 52 cards. Why 52? Because as you can see from the chart, we say if you count all these cards here, it's gonna be 52. So 52 playing cards. So 1 over 52. Now the answer to probability question you can leave as a simplified fraction or a decimal or a percent. So if you figure this out using decimals, 4 over 52 will give us we have with a calculator 4 divided by 52 is 0.0769. So I usually prefer to round it up to 3 decimal places. So this will give us 0.077, 0.077, 0.077, or if you like, or if the question requires it, this is something as saying 7.7%. Now, I usually tell my students, leave your answer to decimal or a simplified fraction. Don't go to percent, because many students, have, when they want to write it as a percent, they forgot to put the percent symbol and write 7.7. That will make you to fail the question, because the probability can never be bigger than 1. So if you want to use the percent, make sure you put the percent symbol. That way you can be sure that the answer is correct. Once you remove the percent symbol, it becomes wrong. So to avoid that, I recommend, unless the question requires you to write it as a percent, leave it as a decimal, or as your answer as a decimal, or as a simplified fraction. Any question on this? Any question?
No question.
Okay, good. Now look at part B. Part B says solution. Probability that the card is a club, a series of club. Let us say a club. If you look at the card here, you can see that these are the clubs, and these are the numbers on those cards. There's only one series of club. Only one club have the number 6 on it. See, and that is this one. So that the probability of getting a series of club, okay, will be equals 1 out of 52 cards. This gives us from our calculator 1 over 52 cards. So I'm going to change this to 1. Give us 0.0193. I know it kept going. So stopping at the 3rd decimal place here, it's going to be 0.019. 0.019. 0.019, or if you like, I can write as 1.9%. Okay, that is for the second one. And for the 3rd example on the classical probability, it says of getting a 6 or a 3, of getting the number 6 or 3 for any of the cards. So I'm gonna move it down. Okay, I'm sure. Okay, this piece might be enough for us. Our solution. Okay, of getting the number 6 or 3. So if you look at here, the cards, these are all the 6, all the cards have 6 on them. There are 4 of them. Club have 6, diamond have 6, hearts have 6, spade have 6. So these are the cards that have 3s. The same thing with the club, have 3. Diamond have 3. Hearts and spade, they all have 3s. So there are 4 on both sides. So the probability of getting a 6 or a 3, so probability of a 6 or 3, probability of a 6 or 3 becomes probability of 6 plus probability of 3. Now, like I explained, for 6, we have 4 cards that have the number 6 on them. And for 3, we have 4 cards. So it's going to be 4 over 52 for 6 plus 4 over 52 for 3, giving us 8 over 52. Because 4 plus 4 is 8. Of course, as you know from your algebra class, the denominator stays the same. Which, if we put on the calculator, 8 over 52 will give us 8 divided by 52. I'm going to change this to 8. 8 over 52. It was 0.153846. Keep going. But we are stopping at the third decimal place, which is 0.154. 0.154. 0.154, or you can call it 15.4%. 0.4%. So I'm gonna fix this problem now. See, 15.4%. So if you have any question, is there any question on this?
No.
No questions.
Oh, very good. So that means we are having fun. Let's do let's try one more on classical probability. Now it says here, let's try another one. Let me try this one. You can try number 5 as a practice, okay? As per yourself, as a practice. I encourage you to do that. Let's look at number 6. Number 6 says solution. Excuse me. Solutions, because I'm going to do all of them together. So solutions. Now, number 6 says 2 dice. 2 dice are rolled. Find the probability of getting the sum of 7, the sum of 6, the same number on both dice, the sum of 11, one number twice the other. Give me 1 minute. Okay. Yeah. 1 minute. Oh. Good. All right. Now, starting with the first one, part A says the probability of getting the sum of 7. Now we're going to use. Remember, we made something like this yesterday, Monday. The sample space for 2 dice, dice 1 and dice 2. So I'm going to copy it, and so we can use it as a guide. Always have, first thing when you are solving probability problem is to find the sample space. If it is, if it is a classical probability, find the sample space. Excuse me. So part A says the sum of 7. So if you look at this chart, what numbers, what combination here give us the sum of 7? Now if you look at this one, 6, 1. So I'm going to write here sum of 7 equals, see, if you look at this one, 6 and 1. So 6, 1. If you 5, 2. Okay, 5, 2. Then 4, 3 also give us 7. Add them together. 4, 3. Okay. Now 3, 4 also, if you add them, it give you 7. Okay. 2, 5. Adams gives you 7. Okay. 1, 6. Adam, they give you 7. See? So that the probability of getting the sum of 7 equal. Now, if you count all these numbers, they are because there are 2 dice. All these sets of numbers for dice 1 and dice 2, if you count them, this is 6, 1, 2, 3, 4, 5, 6. So there are 6. Each of them have 6 numbers, 6 sets, and there are 6 on both sides. So that gives us 36. Sample space will be 36. So you are looking for the probability of getting a sum of 7. Maybe the number of outcomes there that give us sum of 7. How many of them? 1, 2, 3, 4, 5, 6. So it's 6 out of 36, which we can get from our calculator as 6 divided by 36. Okay, 6 by 36. 0.16666, so just 0.167. 0.167, 0.167 is the probability of getting a sum of 7. So because 6 plus 1 is 7, 5 plus 2 is 7, 4.7, you know. Part B says the probability of getting the sum of 6. Let us see the outcome that will give us the sum of 6. Sum of 6. Look at the outcome. Look at here, if you have 5, 1, give us 6. 5, 1, give us 6. Next one is 4, 2. 4, 2, give us 6. Okay. 3, 3, give us 6. Okay. 2, 4, give us 6. Then 1, 5, give us 6. So that the probability of getting a sum of 6, probability of getting the sum of 6 becomes, how many of them? 1, 2, 3, 4, 5. 5 out of 36, which give us if you divide 5 over 36. Okay, I'm gonna change this to 5. 0.13888, that means 0.139. 0.139. 0.139. So that is for sum of 6. As he says, find the probability of getting the same number on both dice. The same number of both dice. Or let us see the outcome that will give us the same number. The same number on both dice. Okay, equals outcome. You can see 1, 1 is the same number. 1, 1. Next one is 2, 2. We have 3, 3. We have 4, 4. Okay, 4, 4. We have 5, 5. Then we have 6, 6. So we have 6 of them. So the probability of getting on the same number on both dice, same number, equals so 1, 2, 3, 4, 5, 6. It's called 6 out of 36 possibilities. So we have done 6 or 36 already here, and we got 0.167. Now, so that will give us about 16.7% chance, of getting the same number on both dice. Now, but this sum of 11, getting the sum of 11. Okay. Sum of 11, let's say the outcome that give us sum of 11, that's part D. Sum of 11 equals, you can only have it here. 6 and 5 is 11, and 5 and 6 is 11. Because if you add them, 5 plus 6 give us 11. So 6, 5. Okay. And the next one will be 5, 6. 5. So 5, 6. So the probability of getting sum of 11, there are 2 possibilities, equals 2 out of 36 possibilities. We give us 2 over 36. That we can get from our calculator as 2 over 36. Okay. 0.05555. So rounded to 3 decimal places give us 0.056. 0.056. 0.056. Okay. So about 5.6% chance of getting that. Now, the last but not the least is to find the probability of getting one number twice the other. Now, this part usually confuse students. I'm going to simplify it. The other. One number twice the other. Okay. Is this. Now, if you look at this, 1 plus 1 give us 2. 1 plus 1 give us 2. See, one number twice the other. So 1 plus 1 give us 2. Okay, so 1, 2, 2, 1. So 1, 2, 2, 1. So because twice 1 give us 2. Twice 1 give us 2. Next one will be, we need is this. We have 3, I think we have 2 and 4. 2, 4. 2 plus 2 is 4. So twice 2 give us 4. And 4 plus 2. Sorry, 2 plus 2 give us 4. So 4, 2, 2, 4. 2, 4. 4, 2. See? Now, another one we need to get is, I think is 6, 3, 6. And 3, 6. 6, 3. And 3, 6. 3 plus 3 is 6. So twice 3 give us 6. So 3, 6, 6, 3. So these are when we say one number twice the other for this particular sample space. That's what it needs. So that the probability of getting one number twice the other equals how many of them? 1, 2, 3, 4, 5, 6. So 6 over 36, which is like I said, we have it already before. So 36 is 0.167. Yeah. Questions for me? Any question for me?
No.
See, I want to. I haven't. I want this week. I wanted to transfer most of your grades from here, but I'm having a busy week, so I will do it in weekend time. So for those of you who are anxious to see your grades in Canvas, just be patient. By the Sunday, I should be able to transfer most of them there. Okay. Now, since you don't have question, let us try one more example on this. Then we can perhaps look at more probability rules. Now it says this. I mentioned at the beginning that many examples will be doing under probability will involve gambling because, like I said, probability theory was actually developed by gamblers who used it to win a lot of money in those days. But eventually it was realized that this theory can actually be applied to other real life situations. So that's why you see. So what you don't say, oh, there are too much gambling examples. But this is why we put them, you know, and also it gives you an idea of how to figure out other problems too. Look at this one. Say a roulette wheel has 38 slots, number 0, 0, 0, 1, 2, 3 to 36. I'm sure you all know what a roulette is. I have it right here. So you put your game, and then if they roll the wheel, if it falls on your if your ball, whatever it is, fall on the number, then you win. I think that's how they do it. Anyway, you can see the 0, 0 here. Then all the 1 to all the way to down to 38 numbers. Anyway, half 1 through 36 are red, and the other half are colored black. You can see the red and black. See, one is red, and another one is colored black. Now you have the green ones, which are the 0 and 0, 0. So the remaining numbers 0 and 0 are called gray. Find the probability of getting that a ball lands on a black number, a green number, a 10, and also an odd number. So let us see how this works. The best thing is to get our, now, remember I mentioned, we know the sample space already, 38 slots. So let us figure out how many balls in each of them. Solution. Okay. Black ball. Let's use B for black. They are half of them, 1 to 36 are red, and the other half are black. See? Half of 1 to 36. That means 1 to 18. If you count them too, if you know like that, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I was counting only the black slots. So 18. And the other half is for the red. So R red is 18. Then the remaining one, the green ones are there are only 2 greens, 1 and this 2. So the green for G for green equals 2 of them. So when you add this total for a roulette, the sample space, now I'll call it sample space. Sample space is you add all this together. 18 plus 18 plus 2. So which we can complete in decimals. Clear on it. 18 plus 18 plus 2. See, 38. Sample space 38. Okay. So you got 38. Now, once we have the sample space, we can now begin to answer the question. Part A says that a ball fell on the black number. There are 18 black numbers. So the probability that your ball will fall in the black number will be 18 out of 38 slots. So we got 18 out of 38 from our calculator. 18 over 38, 18 divided by 38, 0.4736, which is basically 0.474. 0.474, 0.474. Or you can say that you have 47.4% chance that the ball falls in the black slot, you know. So B says, excuse me, it falls on a green number. So the probability of green, there are only 3 green numbers, green slots. So you have it, and it's that only 2 of them. So you have 2 out of 38. So our Desmos calculator, give out the 2, change this to 2. Okay. 0.0526, that means 0.0553. 0.053. 0.053. If you like, you can call it 5.3% chance. That one should be, maybe if you fail on that one, that means because of this slim probability, that means that one, the green slot should attract higher wins. Anybody here played the roulette before?
No.
No? Okay. You say no?
No.
How about you, Mr. Aaron? Have you?
No, I haven't.
Anea? Miss Anea, you there?
I'm here.
Have you played it before?
Have I played what?
Roulette.
No.
Okay. Anyway, but yeah, I'm sure you guys must have seen it in a movie.
Yeah.
Yeah. So this is how they calculate the probabilities. So if you're lucky, if your ball fall in the right slot, you become rich. Anyway, for 10, it says the ball fall on a 10. How many 10s do you have in a roulette? You have only one number that has that. Yeah, this is only one 10, I think. 10. We don't have 10 for this. This is the 10 right here. There's no other number with 10. Yeah, that's not. So the probability of 10, the number 10, on the number, the slot fall on the the ball falls on the slot with the number 10. Okay, will be only one of them, 1/38, which is 1/38. .026. 0.026. Okay. 0.026. Okay. Now we can look at this one. We can call it 2.6%. Now, part D says that it falls in an odd number. Probability odd number. Okay. This gives us this probability. How many odd numbers we have? It says half of 1 through basically 1 to 36 is a combination of odd and even. So 36, so half of it will be odd, because 1 to 36, if you count 1, you count 2, then you count 3. So if you count odd number, even number, all the way to 36. So half of that is 18. So you're gonna be 18 over 36. Sorry, over 38, I mean to 38. So why 36? But why 38? Because this one 0 and 0 0 make a number that made it 38. So now we have it before as it at 8, which give us 0.474, or I call this 47.4%. Questions?
No.
Oh, very good. Very good. Now we are going to examine some basic probability rules. So now, the first rule is the one that is called, I'll call it rule number 1. I actually have it already. Give me 1 minute. I think I have it written already somewhere. Let me move this. See if I can get it from here. Okay, good. We have it already. This is the first rule. It says the probability of an event E. Okay, good. Is a number which can be either a fraction or a decimal or percent between as and including 0 and 1. So this is how we write it. Probability of event E is less than or equal to 1, but greater than or equal to 0, which means that the probability of an event can never be less than 0 and can never be greater than 1. This 1 represents 100%. This 0 is 0%. Let me make them a little bit bigger. Okay, so you can think make it 14. Good. Now, second one is this: if an event E cannot occur, its probability is 0. So that the probability of an impossible event is 0. A good example: the probability of getting a 7 in a single dice, in a single 6-sided dice, is not possible. So it's an impossible event. The third rule says if event E is certain, then the probability of E is 1. So now a good example of this event, well, all things being equal, the probability that I will wake up tomorrow is 1. It's 100% sure. All things being equal, as we say in economics. So now rule number 4: the sum of all the probability of an event in a sample space. If you add all the probabilities in a sample space for that event, it will give you 1, total of 1. And I'm going to illustrate this using an example. Let me illustrate this using an example. So suppose we have this. Excuse me. Suppose we use a dice. Let's say I use a dice. A 6-sided dice. Okay. To illustrate this, outcome and its probability. Outcome S, X. Okay, and the probability of X for a dice. In a dice, the first sample spaces can be, see, 1 can show up, number 2 can show up, number 3 can show up, number 4 can show up, number 5 can show up, number 6 can show up. So the sample space. So now, for each of them, like I say, a dice, or I have my dice, has 6 sides. 6 sides. So for each of these numbers showing up, the probability is 1 out of 6. 1 over 6. For 2 is 1 over 6. For 3 is 1 over 6. For 4 is 1 over 6. 5 is 1 over 6. For 6 is 1 over 6. So the total, they all have the same denominator. And for your algebra class, you know that when they do that, the total will be 1 plus 1 plus 1 plus 1 plus 1. So it does give us 6 over 6, which is equal to 1. So that's what this rule number 4 is saying. That the sum of the probabilities of all the outcomes in a sample space equals 1. Okay. Now, next one we'll be looking at the complement rule. We'll start from complement rule on Friday. Any question before we leave?
Yes, remember last week when I mentioned about the test when you assigned the test and I couldn't complete it because of my I have the account now. So
yeah, I remember you told me Monday. I think you said that on Monday, right?
I don't know which day, but yeah, I told you last week when you assigned the test that I couldn't complete it due to the fact that I didn't have the trial.
Okay, what I'm gonna do is this. When I'm gonna check it. I'm behind on so many things this week because it's a busy week for me. But I'm gonna try and check everything this week. If it's not there, I can put it back for you. And then if it's not completed there, I mean, when I log in, if I don't see a grade there, then what I can do is to put it back for you to complete. Okay.
All right, that's fine.
Something with Miss Bennett, right?
I'm sorry, what?
No, I'm talking to Miss Bennett. Miss Bennett, the same thing applies to you. One you missed, since now you have the account. Okay.
Okay.
All right. I see you guys on Friday.
All right.
All right. See you.